welcome to our college calculus. Today I will teach you differentiation of rules, the product and the quotient rules. I will divide my class in these two topics. I will teach you first the product rule, and then after the last moment of my class, the quotient rules. Okay. What is the product rules? The product rule, if, for instance, if F and G, for instance, okay, are both differentiable so then we have this formula, d divided by of dx, open Quotient right here, and then right here f of x, and then g of x, I mean times, right? So you have this, and then we have this problem, and then this will be equals f of x. All right, so you development this d of x times, open parenthesis, we will have inside the quotient g of x, okay, plus here, look at this, plus g of x. All right, d of divided by differentiation of x, inside we will have f of x. All right, let's see, this is the main concept about how work and the product rule. So in other words, this means the product rule says special that the derivative of a product of two function, it is the first function times the derivative of the second plus the second function times derivative of the function. So this is this concept. All right, the product rule. So the derivative of the product right here, of the product, we have the product of two functions. We have f of x and g of x. It's the product of two functions. Is the first function times, the first function times the derivative. I mean the derivative of the second function, plus the second function times the derivative of the first function. All right, that is why I write it in this formula. Let's go and try to solve. Let me solve one example. Okay, let's write 2 questions here. The first one, all right, let's write if f of x equals, look at the x e to the x power, all right, we have to find here, find the derivative. This means the derivative of f of x, right? B, this is the second question, find the nth derivative like f to the n power of x. All right, two questions there. What is the solution to this problem? The first one, and the first problem, we have to find the derivative of x in the first case. So let me write down the process right here and the first one. All right, we have by the product rule here. So we have f of prime of x. So this will be the derivative of x e to the x power. All right. So this is equals will be equals. How solve this problem? How solve this problem? So we have to write x times derivative of x e to the x power plus e to the x power. Remember the rule that I wrote before, times derivative of x. All right, that's you follow the rule. Okay, and then you solve this problem. We will have here x times e to the x power plus e to the x time 1, right? So this is equals here x plus 1 times e to the x power. All right, this is the solution to the first question. That's the solution of the first question. All right, so let's go and then find the solution to the second one. All right, now let's solve B. Question B, find the 10th derivative. I mean, f to the n power of x. Okay, here we have to write using the product rule. Okay, using the product rule a second time, we get this problem here. So f, so the second times the second derivative of x is equals derivative, I mean differential of the dx, open parenthesis, I mean quotient right here, quotient, write it x plus 1. Remember we got it first time this solution, remember, e, because now it's the second time. See, so now we will have here x plus 1 times d x times e to the x power, right, plus e to the x power times x plus 1. Okay, just follow the rules, just follow the rule. Our conclusion will have x plus 1 times e to the x power plus e to the x power times 1. You simplify this. If we simplify this, we will have x plus 2 times e to the x power. And then this is the solution, right? This is our solution to our second, the question B. Find the derivative f to the n power of x. All right. So in fact, if you want to see some conclusion here, so here, in fact, each successive differentiation in our problems, we have to add this is very important, add another term ex. So as a conclusion here, so that's very important, this little thing in our problem. So our formula f to the n of x is equals, it's a formula conclusion, x plus n, in our case, times e to the x power. All right. So this is very important to write here when you finish on our problem. All right. That was our first problem. Can I erase it? Let's erase it and let me show you another problem. Product rule. Problem number 2. That's very easy. Let me show another. Let me show you another example. Example number 2. All right. Example number 2. Let's let's write our problem. If f of x equals a square root x g of x, where g of 4 equals 2. See, this is a little different to our first problem. And g prime of 4 equals 3. So we have to find here, find f prime, the derivative of 4. So what is the solution then? Solution. So here, if you apply the product rule, we will have, let me write the whole problem here. If you apply the product rule, we will have f prime of a derivative, in our case, a derivative of x equals the differential of d of x. Open Quotient, we will have here our problem, the square root of x and then g of x, right? So now try to develop our problem. So first step, we will have the square root of x different times g of x. G, we have to write Quotient right there. So plus, now we have to add it, gx, the second one, remember the first one and then the second one, gx times the derivative of is the first one. The first one we have a square root of x, right? That's it. That's the first step. Now you simplify here all these problem. we will have square root of x and g prime of x plus this section, this second section, g of x times 1/2 of x to the negative 1/2, negative 1/2 power. All right, this is times. So now we have simplify here. The square root of x, g prime here of x plus here g of x divided by 2 times the square root of x. All right? When you simplify this part, this fraction, this complex number. So then our conclusion, our answer, look at this. This is very important. It is, f of the derivative, the derivative, find this of 4. Okay, so it's equals square root 4 here, and then g prime of 4 plus g of 4 and 2 square root 4, right? If you simplify this, all these terms of here, we will have 2 times 3 plus 2. You get some confused, just try to follow all direction. I give it to you the concept at the beginning. So, but you use I'm using my calculator to find the answer. I don't have enough time to develop the whole process and looking for the answer. But the answer here is 6.5. Check your problem, and then that's the answer. So this is the solution for our second problem of how apply the product rule. It's very important. All right, let's go. Now let me explain it to you. The quotient rule. Okay, quotient rule. As quotient. All right. What I mean quotient rule? Okay. If f and g, again we're talking about f and g, are differentiable. So then we have this formula. Again, I want to write I will write the formula right here. So d divided by dx. So now it's not product, now it's division, right? We have to apply division. So we will have f of x divided by g of x, all right? So this is a division now. So here we will have very long fraction. Very long fraction. On top, we will have g of x divided times dx here times f of x, close right here. Now subtract f of x. Now we have to subtract times d of dx of what? Of g of x divided by, open curl right here, g of x to the second power. That's actually the definition. This is the concept of definition. What is the formula that we have to follow to solve quotient or problems we applying the quotient rules. Okay, this is our formula. Okay, got it? Take a picture or check the video back to see how apply it. So now see one example. It's easy to understand this. So let's write this problem. So let y equals, let's see, it's not hard, x to the second power plus x minus 2 divided by x to the third power plus 6. Okay? So then y prime or derivative will be equals, remember the formula I give it to you before? That's the example, the formula that we have to follow. So it's again, it's long, very long, the formula. Let's write right here. We have x3, x3, x to the third power plus 6. All right? Right here. Times, we have to write this trinomial right here. X, or polynomial, to the second power plus x minus 2. Okay? Minus, I will use another color because it's very close over there. Minus, again, we have to write x to the second power plus x minus 2, right? Times, we have to write right here d divided by dx times x to the third power here plus 6. Right, and then in the bottom we have x to the third power plus 6, all these to the second power, right? Remember the formula? So I give you all numbers here. So now we have to simplify all these polynomials. It's long, very long. Again, on top we will have here this one, x to the third power plus 6 times 2x plus 1, right? Minus x to the second power plus x minus 2 times 3x 3 to the because it's a derivative. We have remember this number, this derivative right here. There's the derivative of this one is 2x plus 1. Derivative of x to the third power plus 6 is 3 to the x to the second power. And the bottom, so just write it again. X to the third power plus 6 to the second power. Okay. Continue. Let's continue simplifying here in our problem. And the first polynomial, if we multiply this, we will have 2 x to the fourth power plus x to the third power plus 12x plus 6. It's a product. It's a product of these two binomials. All right? Minus, multiply this, we will have 3x to the fourth power plus 3x to the third power, see this, minus 6x squared. right? Subtract those. X to the third power plus 6 to the second power, right? Simplify here. Is just follow direction. It's no problem. It's very simple. It's very simple. It is not hard. All right. So you subtract this. This is remember I made to you before. I explained it. This kind of problem. The subtraction of the two binomials. So we will have x to the fourth power here minus 2x to the third power plus 6x to the second power plus 12x plus 6. All right. Divide by x to the third power plus 6 to the second power. So this is our solution. All right. Sometimes some student ask me, why do this? Why don't do the whole process? Like for instance, right here, write this subtraction and then development step by step. Remember, our class is college calculus. We are not in algebra 1, we are not in algebra 2, we are not in calculus of high school. This is calculus for college. It's college calculus. And then it's a little bit hard. That's why I'm trying to push the student and you guys by yourself. Try to make all operation, all step you want to do. Also here, you subtract this, and then you will have this answer. Okay, so this is the solution for our problem. Got it? It's done. Let me show you one more example. Let me show you another example. It is nice. It is not hard. It's very easy. It's very easy. But just practice. So on this problem, let me write the problem. Find an equation here. Find an equation of the tangent to the curve y equals e to the x power divided by 1 plus x to the second power at the point it's a problem. This is a point. It's a 1/2 e. This is the point. So what is the solution here? How find the solution? So this problem is a word problem. I will have applying the quotient rule. If you apply the quotient rule, we will have at the beginning this step. Let's write it right here. D y divided by dx is according to quotient rule. Remember, this is a quotient rule. We will have on top. That's why, remember, I give it to you the formula. Basically, I give it to you the formula. Just follow that formula. Just write one right here plus x to the second power times d divided by dx of e to the x power minus e to the x power. Then this is derivative times of x of the first 1 plus x to the second power, first term. All right, divided by here 1 plus x to the second power right? All right, if we simplify this, we will have two, this right here, we will have 1 plus x to the second power times e to the x power to the x power minus e to the x power times 2x. This divided by 1 plus x to the second power to the second power. So equal, simplify. We're able to simplify. We will have e to the x power right here, right? X power, x. This is x. Oh, it's not fine. Okay. Right now, where you go? Times 1 minus 2x plus x to the second power plus x to the second power. Divided by, again, in the bottom, this is the denominator. X to the second power to the second power, right? That's it. So if we simplify here, we are here, it will be equals here e to the x power times 1 s minus x to the second power here divided by 1 plus x to the second power to the second power. So this is the solution. That's the solution. So, but find the equation of the tangent line to the curve. So if we make the picture right here, let's let me use this. Let's make the picture right here. I will to make the picture right here. This is the square. So I have this number right here. You divided this section right here in 2, 2, 2, 2. This is here. Let me give it to. Let's write the number right here. This is a negative 2 right here. Negative 2. This is 0. This is 2.5. And then here as 3.5. Let me write it right here. 0 is negative 1. 1. 2, 3.5. And then it's 2. Let's write right here. Yeah, like this. Then let's make the graph. The graph is running like cross right here. It's moving right here. So the graph right here, and this we have y right here. Y equals e to the x power divided by 1 plus 2 plus x to the second power. Okay, and then here we will have y equals 1/2 e. So this is our graph of the problem here, right? This is the graph running like this. Let me remark right here. I think that's fine. So this means the tangent line. The tangent line is at this point 1/2 e. This is the tangent line. Is right here. It's horizontal right here. So horizontal right here. Look at this point right. This right at the point right here. It's horizontal line. So this equation is y 1/2 e. Y equals 1/2 e. So the tangent line is at this point. It's y equals 1/2 e. This is the tangent. The tangent line y is asking in our problem here. What is find the equation of the tangent line at the curve. So this is the equation of the tangent line at the curve, in the curve right here. So this is our problem. All right. So in general, I show you how work this topic in college calculus, differentiation rule. So one is the product rule, which I give it to you 2 examples, and the quotient rule. This is the last example. So thank you so much. I'm waiting for you next time. Thank you.